Today, this presentation outlines our final project for Net 313 Advanced Networking, focusing on the complete design and implementation of urban Looms enterprise network infrastructure. This project focuses on the operational structure, network requirements, VLSM addressing, WAN formation, routing processes, DHCP services, and the results of network testing performed across all sites. Urban Loom operates three key locations. The first one is the headquarters, central office for administrative, financial, HR, IT, and server operations. Next one is the physical store. It handles walk-in purchases and point-of-sale transactions. Lastly is the warehouse. It manages inventory, scanning, packing, and fulfillment. These three locations rather exchange information continuously: inventory levels, point of sales updates, HR records, financial data, and shipment status. To support this, the network must remain stable, secure, and scalable, enabling uninterrupted communication between all branches. Without a network, the three urban loom locations would remain isolated, preventing the sharing of inventory, financial, and operational data. By connecting the sites through routers, WAN links, and proper IP addressing, communication becomes seamless across all branches. This interconnected system ensures synchronized workflows and reliable company-wide coordination. Based on the needs of the three locations, several network requirements were established. The first one is the consistent bandwidth for branch operation, scalable VLSM-based addressing, centralized DHCP management, secure administrative access, and lastly, dynamic routing for effective inter-site communication.
Urban Looms network follows a centralized WAN architecture. The headquarters router forms a dedicated point-to-point serial links to both the store and warehouse, enabling controlled and manageable intern-branch communication. Each point-to-point connection uses a dedicated subnet mask of 30 network, providing exactly two usable IP addresses, one for each router in the link. This ensures efficient address usage and clear separation between the headquarters store and headquarters warehouse one connection. To support local operation, the internal network were subdivided using VLSM within the IP address of 192.168.10.0 with a subnet mask of 24 block. In the headquarters, with a subnet mask of 26 with available host of 60 hosts for administrative devices and servers. In the physical store, with a subnet mask of 27 with available host of 30 for points of sale and local system. And lastly, in the warehouse with a subnet mask of 27 with available host of 30 for inventory and logistic devices. This structure not only matches current devices requirement but also maintains scalability. A 24 block allows one subnet mask of 26 network and up to 60 branch network, meaning the current device can still accommodate 4 additional branches without modifying the original addressing plan. Before DHCP relay can open across the network, the dedicated DHCP server located at the headquarters must first be configured. The server assigned with the IP address of 192.168.10.10 contains all DHCP scope for each branch. In the HU, the IP address is 192.168.10.0 with a subnet mask of 26. In the physical store, the IP address is 192.168.10.64 with a subnet mask of 27. Next, in the warehouse, the IP address is 192.168.10.96 with a subnet mask of 27. Each scope specifies the correct default gateway, subnet mask, and DNS server for each respective location. This ensures that all devices across the organization receive accurate and consistent IP configuration. Since DHCP uses broadcast packets that cannot pass through routers, devices in store and warehouse would not be able to reach the DHCP server directly. In configuring all routers, the process begins with establishing the essential baseline settings. We start by assigning a host name to each devices to ensure clear identification during management and troubleshooting. Next, security settings are applied, including encrypted password, console protection, and VTY access control to ensure that all devices are managed securely.
After securing the device, LAN and WAN interfaces are configured with corresponding VLSN-based IP addresses to establish local connectivity and inter-branch communication. Even if the server is ready, the store and warehouse devices will not receive IPs unless their routers are configured with IP helper address because DHCP broadcasts cannot pass through routers. Finally, EIGRP is configured to provide dynamic routing and efficient network learning across all sites. We will begin by checking whether each device across the headquarters, store, and warehouse successfully received an IP address from centralized DHCP server. This involves opening the IP configuration for each client and verifying the assigned IP subnet mask, gateway, and DNS values match the expected setting of their respective subnets. Next, we will test device connectivity by using ping command. This allows us to confirm whether each branch can reach its default gateway and communicate with the other branch across WAN. After confirming connectivity, we will examine the routing tables generated by EIGRP to ensure that all LAN and WAN networks have been properly learned by each router. The presence of dynamically learned routes will validate that EIGRP is functioning correctly. Finally, we will test network resilience by simulating a one-link failure. By shutting down the serial interfaces on the headquarters router, we can observe how EIGRP updates the routing tables and how communication behaves under link failure conditions. This test collectively confirms whether our configurations were applied correctly and whether the network is stable, functional, and ready for full operation. All diagrams, calculations, routing tables, DHCP lists, and pin results were documented. The final network design is secure, scalable, efficient, and support continuous communication between all urban loop sites. Thank you for viewing this presentation for Net 313. This concludes our demonstration of the Urban Dome network architecture.